All right, welcome back. I think this is the last section. So, how do we interpret depositional environments? If I'm looking at some rocks and I'm looking at a cross section or an outcrop or a vertical stratigraphic column in the lab or something, what the hell am I looking at? How do I kind of interpret all of this? So, for example, what do you notice here? Hopefully, a couple of things. First, layers. But as you look closer, I would hope you would be able to see, let's go to the next slide, some of this. This cross-bedding. All right, this is cross-bedding. So what we have here, so we have sedimentary rocks with cross-bedding in it. So what does that tell us? Just for reference, this is the name of this rock is the Navajo sandstone, typically found in the southwest U.S., like here in Arizona. It's Jurassic in age, comes from the Jurassic period. The sediment was deposited in the Jurassic period. Remember, Jurassic, like Jurassic Park, is one of the three periods in the Mesozoic era, which dinosaurs existed. More on that in a second. So it has features of wind-blown sand dunes. That's the cross-bedding. All right, it has indications of wind-blown sand dunes. The sandstone is, if we were able to kind of look at the sandstone more closely, maybe under a microscope or a magnifying glass, the sandstone is well sorted, so it's made up of, about the same size material. Well-rounded quartz, so the quartz grains really got kind of blown and battered around. We know it's land-based sand dunes because we see tracks of land-dwelling animals, including dinosaurs. So there's tracks of land-based animals, so most likely this is land-based sand dune cross-bedding. The cross-beds have wind current ripple marks. The cross-beds all generally dip in the same direction, so you can figure out in which direction the wind was coming from, the prevailing wind was coming from as this was created. So that's kind of how you interpret that. Okay, sedimentary rocks. Okay. Well, what type? Sandstone. Okay. I also see cross-bedding in there, and I see animal tracks. So I must have some land-based, cross-bedded, sand dune-based sandstone. There's dinosaur tracks from a particular dinosaur. Oh, this must be Jurassic in age. Remember, you can't date sedimentary rocks directly. You have to use fossils or other rock types to do that. Another example. So in the Lower Silurian period, there was some strata exposed from the Lower Silurian period in New Jersey and Pennsylvania. What we can figure out from this is that from the different types of rocks, we can then infer the environment. So New Jersey, I don't know if you know this now, is right on the coast, right on the ocean. But yet, here's some mountains. Pennsylvania, central Pennsylvania, is much higher in elevation than New Jersey. What this is recreating what this area looked like in the past. So New Jersey had to be higher in elevation than Pennsylvania at some point, because what we see the rocks doing is we have some conglomerates, bigger pieces, kind of getting smaller in size, downgrading to sandstone. The facies are changing. So what this is indicating is that the sediment source, mountains, usually if we have kind of conglomerates and bigger pieces, the bigger the pieces in sedimentary rocks, the bigger the grain size, the closer to the sediment source, in this case mountains. And so we get finer and finer grain materials as we get further and further away. Water can carry smaller materials further. So the conclusion is that sediments were deposited in braided streams that flowed from east to west. Now in the area, all streams flow west to east down to the ocean. So this must have occurred when the geology of the East Coast was a lot different. Remember, plate tectonics plays a part in all that. Okay, Ordovician rocks in Arkansas. So we have indications of transgressive shelf carbonate deposits in Arkansas. So that helps us infer, well, that type of environment covered Arkansas at one point in the past. The trend overall was transgressive, so these rocks indicate sea level rise, but you do get some regressions that occur. So, sorry about the little hiccup. There was outside of the hotel and where I'm staying at for the conference that I'm at, there was just horns honking and blaring, and it got a little much, so I had to go back and kind of pick up where I left off. So in any case, so these Ordovician rocks indicate a depositional environment that was transgressive, sea levels rising, depending on the particular facies we're looking at. So kind of subtidal environment, limestone, kind of tidal, intertidal environment, and the type of rocks that are kind of super tidal beyond the high tide. So what we see going on here, basically in all these different limestones, where reefs and fossils were located, we tend to get mud cracks in certain areas, so we know those areas were exposed to air. So we see kind of a series of, if we look here, transgressions going this way, regressions going this way, but ultimately led to a transgression. So from here to here, ultimately we're leading to a transgression. Ocean levels were rising. So we're trying to infer all of this stuff again to help us recreate the past. We're trying to read rocks to figure out what they tell us. So in paleogeography, so that deals with Earth's geography, kind of the surface and the layout of the past, using interpretations of depositional environments. So if we wanted to recreate, like you've seen in some lectures past, or in some of those websites that have recreated where the continents were, some of the different supercontinents, it wasn't just evidence that they stuck together, but we use all this other kind of evidence to figure out the orientation. What else was there? How high or above sea level was an area? How below sea level was an area, depending on what sort of sediments and sedimentary rocks and fossils, all of these things help us recreate the past. And that's what paleogeography is, looking at all of this to figure out the geography of the past. Not geology, but geography, just kind of mapping things out where things were. For example, we just saw the Navajo sandstone. It shows that vast desert was present in what is now the Southwest during the Jurassic period. So the vast sand dune desert, which we don't have now. So that's kind of different. So that helps us to recreate what the area looked like. And also from another fun example, from the late Precambrian to the middle Cambrian, so back in the Cambrian period, the shoreline of the ocean migrated inland from east to west during a marine transgression in North America, meaning ocean's level rise. If you can imagine, from the Mississippi River, as sea levels rise, that oceanic water came further and further and further west. So the deeper parts were going to be out west, the shallower parts are going to be to the east. The deeper parts are going to be in the east, the shallower parts are going to be from the west as the sea level rose, starting from the kind of interior of North America. But detailed studies of these various rocks in the western states allowed us to determine that with some accuracy. Not only once, but multiple times. For instance, this is an example of how the area appeared during the late Cretaceous. It's the last period in which the dinosaurs existed. We had a broad coastal plain sloped down gently eastward from a mountainous area down to the sea, down to the ocean yet again. So we had actually more of a large mountain range in this area. And as we kind of move in this direction, we get stones, so we have sedimentary rocks that indicate deeper and deeper sea levels. Later, kind of in the same area, vast lakes, river floodplains, alluvial fans covered much of this area as the sea had withdrawn from the continent, so we might have some limestones or other fine-grained sedimentary rocks now covered with bigger grained and differently sorted and rounded sedimentary rocks that covers up the limestone, so we're indicating sea levels falling, changing of environment. It tells us so much. It's easier said than done. I'm not expecting you to, in, for instance, lab to show you a rock per se, and you to tell me, oh, everything based on that. But rocks tell one hell of a good story. And in fact, if you're looking at, say, a piece of sandstone, which is a rock that's made up of sand particles cemented together, you can kind of imagine that. But even if you didn't know it was a sandstone, the name, based on its texture, you can still start to infer things. So that's why I was never too big on the names of rocks and minerals, and why for myself, I have never really memorized a ton of names of rocks and minerals, because it's more so the story that it tells that interested me. So it's more so looking at a rock and saying, oh, okay, I get what's going on here. Oh, this is igneous, extrusive volcanic igneous rock. That means a volcano around here. Oh, this is a limestone. Oh my gosh. What's the name? Maybe I put a little acid on it and say, oh, I don't know the name, but it bubbles. It's made up of calcite. That must mean this was deposited in the warm, shallow seas of the ocean. So it's not necessarily the name of the rock, but more so the story it can tell you. And the more you practice that, the little bit easier it's going to be. Again, I know you're not geologists, but being able to think and reason and infer are practical skills that you can take with you wherever you go in life, no matter your major, no matter your career. So while, yes, this is a geology class and we learn geology, what's more important is how you go about that, how you think about things, how you solve certain problems, your ability to function on a computer. Hopefully that's getting better and better and better as you go. The ability to have good written communication. So someone who's never really met you, me, is trying to figure out what the heck you're talking about based on, just what you're sending me. So these skills are what's important. These skills are what we're focusing on. Yes, we have to learn geology, and that part can be complicated as well. Ask questions, slow it down, think, reason, take some time, attempt to get ahead as best you can. I know that's limited by, we all have family, we have jobs, we're trying to do school, I get it. So trying to get ahead is easier for some, harder for others. And then myself as well, trying to stay ahead in this class. I'm making all of this stuff as soon as I can to get it out to you all. Will it be perfect? No. And again, I remind you, if there's any issues, please, please, please let me know, and I'll try and fix things as best I can. But in any case, extreme side notes to the end of Unit 6 lecture, I guess. But just a reminder, these are some of the things to be successful in this class. I want you to succeed. I want you to get a great grade. I want you to get the grade that you want. Ask me for as much help as possible if you can. Try and get ahead if you can. Again, life happens. I get it. But in any case, it's been my honor. It's been my pleasure. So until next time, this is the end. I'll see you next time.